Leeway Odyssey, Gulf of St. Lawrence.
Cape Breton is known to the Mi'kmaq as Unama'ki, meaning land of fog.
An illustrated map.
Just off the island's west coast is a submarine feature called the Cape Breton Trough. Here, we make contact with the Canadian Coast Guard vessel, the Martha Black.
So there's at least 5 pelican cases that need to go across.
This is our chance to explore the bottom of the ocean, known as the benthic habitat.
The team is driven to the Coast Guard ship in a Zodiac.
But the Gulf has an average depth of 150 meters. So we need some help from a special piece of equipment.
Isabel Hurley.
I'm standing here on the Martha Black, and Martha Black is housing ROPOS, an underwater robot that's going to go explore for the very first time the seafloor of the Cape Breton Trough.
Dr. Boris Worm.
We're hoping to explore those lesser-known habitats, those places where other species live, and really to see for the first time what it's like to be down there and who lives there, and whether it's any species that we place particular importance on and that we're trying to protect or recover because they've been depleted in the past. So that's our mission, but we don't know what we're going to find.
The square yellow robot sits on the deck of the ship.
ROPOS stands for Remotely Operated Platform for Ocean Sciences. It's engineered specifically to be pushed to the limits of deep sea exploration.
The system is rated to go 5,000 meters.
Wow.
Mechanical claws.
We call this the business end, all our lights and our cameras, and this is where we do all our work out front here with our arms. Go ahead and stow.
A camera lens swivels.
This camera is on an extend and retract and pan and tilt. The video image gets converted to an optical fiber, and that optical fiber runs straight from right here all the way up into our control van.
A roll of thick yellow cable.
So inside that yellow cable, we have one fiber for our HD cameras, and we have 2 fibers that run our telemetry system, which controls everything.
These fiber optic signals travel at roughly 200,000 kilometers per hour. So fast you can see what's happening in real time.
Isabel watches a video feed from the seafloor.
The lighting is important. We've got lights that are a lower color temp and a higher color temp. So some of them travel farther in the water, and then other ones give a nice warm light to the image and a more color accurate balance to the image.
Plastic canisters mounted to the body.
But ROPOS isn't just sending back images. It can bring back physical samples too.
Those are the suction samples. So we have an underwater vacuum. That's what this is.
A hose on a mechanical arm sucks up a sea pen.
Those are all places where we can put our samples. We're taking sediments here for a scientist that's analyzing sedimentation around sea pens and all that.
Yeah. The operators must have such steady hands to be able to put it back into that tiny hole.
It's so precise.
Yeah.
It's really incredible to see.
The arm lowers a plastic tube of sand into a narrow canister, a yellow shipping container.
That precision work is done by a dedicated team in a shipping container on deck. But this is no ordinary container. It's a custom-built, high-tech robotic control room.
So it is like flying an airplane or a
Yeah, we
spaceship.
call it piloting or flying the ROV.
Yeah.
This will make it go down, and then this will control the horizontal movements.
Okay.
This matches the different joints on the physical arm on the sub. So when you move this left and right, that moves the wrist on the arm left and right.
The mechanical arm moves as the pilot adjusts the miniature. Dr. Worm points to a black sign on the ROPOS.
I love that. How's my driving? I break for sponges.
The ROPOS team inspects the machine on deck.
Before ROVs like ROPOS, the only way to gather data about the ocean floor was by dragging the bottom with fishing trawlers.
Up to this point, all we did is sample destructively, right? And sometimes I wonder, if aliens wanted to learn about the Earth, and they would come down and say, we wonder what this place looks like, and they would drag across the city, and they go, oh, that's what they are, that's how they live.
Yeah.
Right? It wouldn't be very representative.
No, so it's super cool that this is the first time that they're going to be able to examine the habitat without completely destroying the habitat structure, yeah.
Oh, here we go.
Isabel and Dr. Worm watch from an upper deck as the ROPOS is lifted on a cable.
The seafloor tends to get hardly any attention, and it's because of tools like this that we're able to finally examine the benthic habitat of the ocean. This is super exciting.
Okay, go ahead, release.
The cable detaches and it sinks below the surface.